Chapter 14, number 62. When you blow across the opening of a partially filled 2-liter soda pop bottle, you hear a tone. A. If you take a sip of the pop and blow across the opening again, does the tone you hear have a higher frequency, a lower frequency, or the same frequency as before? And then choose the reason why. Here's the important bit. I'm going to take quite a gulp instead of a sip. What ends up mattering really is that there is a significantly lower level of liquid in the tube, which is not so important. What's really important is that the length of the tube of air has gotten longer. There's more air inside the bottle. And it's the column of air that's going to be the most important thing for us here. We're in a new frequency, which we'll call frequency B. Both of these are fundamental frequencies. They're going to be produced by the quarter wavelength bit, at least overwhelmingly, because really many frequencies are excited, but the lowest excitable mode takes the vast lion's share, most of the energy, so we can usually say that. And in this case, with no restrictions, the lowest available mode is the fundamental mode. Remember that for a closed pipe, the fundamental mode, if it's closed at one end and open at the other, is the velocity over 4 times the length. And so we can see that as the length gets longer, the frequency gets less. So we would expect that this would be a lower, we get a lower frequency. And the reasoning would be a lower level of pop results in a longer column of air and hence a lower frequency.